Good morning. My name is Shivshankar Gutlapalli. The project is Predictive Mission Status Analysis using sensor data. And let's just dive into the presentation. So actually, like coming to the introduction of predictive maintenance, it involves as you know the data analysis, machine learning to predict when we will need the equipment maintenance or it's mostly used in the industrial settings either to optimize the maintenance or check whether it's if it's a downtime and minimize them and also the reduce cost. And the main methodology for this methodology includes it has data processing, exploratory data analysis, feature engineering, predictive and modeling. So these what do we do is in this project we employ sensor data analysis and we will do some machine learning algorithms so that we can predict the equipment status and the maintenance needs. And yeah, so the we'll just see how the data processing and analysis work. Like it's a initially we have to we have initially we'll do it either with a visual representation, cleaning and parsing data time, and the handling missing values. The first one is visual representation. Like we use the either histograms and the time series plots. We do this either to either to understand the distribution and also the sensor data, how is the spike in the sensor data, everything, the patterns. We also it also helps us in providing the insights for the analysis and modeling. And coming to the cleaning and parsing data time, so here we do it for the accurate analysis. We see if there is we see if there is any discrepancy standing in formats, and that we'll ensure there is no data consistency. So we if we handle if we handle this perfectly, it will contribute to the better analysis and the and the effective model performance. And also the last thing is the handling missing values. It is used for example we I mean we use the handling missing values in the data set to either to ensure that the reliable the analysis is reliable, such as we remove which we don't need. And also we'll check if those missing data leads to leads to the betterment, or also it leads to quality of insight. It's like that. And also this is how we do the exploratory data analysis. ED is nothing but it's a phase in any project. It will provide the insights, the structure. If you see the over here, the sensor 7, sensor 9, sensor 8, sensor 10. So it's all it all shows the distribution of the sensors. It helps us to identify the patterns, anomalies, everything, and the correlations like that. And we can also the next slide is visualizing the sensor data trends. So here the initial thing is the anomaly detection. So for example anomaly detection techniques are Z technique, Z score, or the isolation forest. And those we do it to identify the unusual patterns. If you see over here, it's like the sensor is 1 2 3 4 5 6 7. We do this either to indicate if there is any malfunctions or the errors or any changes, abnormal changes, anything, to detect those and to indicate that this is the it's kind of anomaly detection. That's what it is. And the techniques we use is here is the importance of feature selection algorithms, like the recursive feature. And we'll apply this and we'll apply these in order to identify the most informative sensors, the which helps us in the features for predictive equipment status. And as we told, by conducting EDA we gain valuable insights to the characteristics of data sets. We identify the potential changes, opportunities, and we'll it's inform the subsequent step. It's like kind of predicting what happens, like this. If you see over here, such feature engineering, model selection, evaluation, like that. So we'll see how the correlation analysis work. Initially the correlation analysis, if you see, it is performed to quantify the relationship. We have the sensor readings and we have this, we have the equipment status. So we have to kind of correlate, correlation analysis, we'll do that. And after that we'll take those coefficients such as Pearson correlation or this PMN that are computed, and then we'll use those to measure the strength and direction of linear relationships. Then we use a heat maps, either to visualize the correlation matrix with different colors, so that we can identify them. And also in correlation matrix plot, we different colors represents like a strength and direction of correlation pairs, and then the variables the color. Okay, see here we see the correlation analysis. If you see over here, it has different like different colors. If you see the sensor 1 to sensor 50, sensor 1 to sensor 50. So the correlation matrix, if you see, this is a point 0.4, point 0.2. So depending on this, we get the correlation matrix, and if you see, the dark blue is strongly negative and the light blue is weak negative. White is no correlation, like it's like no relationship between the variables, and the light red is kind of like weak positive. It's kind of close to zero, like it has some tendency, it's like the relationship is not strong or something, and everything is mentioned over here. And based on those calculations, like between each column and the mission status, we have the sensor ratings like this, it has different degrees of correlation. So if you see, the highly correlated sensors are 4, 10, 11 to 12 and 50, and the moderate we also have the moderately correlated sensors, and the low correlation or the no correlation. And the next one that comes is feature engineering. So the feature engineering, here, if you see, these features provide valuable insights into the equipment and performance. So if you see over here, we have the timestamp, we have the sensor, we do the sensor 00 ratings over time by mission status. Here the trend analysis techniques, it will include the slope and intercept, intercept calculations. So if you see the ratings, a mission 0, 1, 2, so depending on that, what is the status, and also there is also something called as time lag variables, which time lag variables plays a significant role in capturing those the temporal dependencies and historical context within the sensor data. And next thing is a predictive modeling. So over here, now we have the considered overview of machine learning algorithms is considered for predictive modeling. So we are linear regression, logistic regression, random forest, SVM, anything. So here what do we do is, criteria to use, the best thing is we have to find the best performing model to predict, because at the end of the day we need the predictive modeling. So the selection criteria itself, itself has an importance of choosing the robust and accurate predictive maintenance. And also the model training and evaluation metrics is nothing but the explanation of model training pros and evaluation metrics used to assess model performance, such as what the accuracy of it, precision of it, recall, F1 score, everything. This, not everything, sorry. So we'll just go to the what is evaluation matrix, and it's kind of a detailed evaluation matrix for each machine learning algorithm. It will highlight the performance of random forest. So if and also the evaluation matrix provides insights into model accuracy, precision, as I've told before, models accuracy, precision, recall, and F1 score. So if you see over here, these are if you see this is a logistic regression, this is a random forest, and this is a SVM. So for this, we'll see how those we'll see the predictive emission status and the index. So if you see actual emission status, red is a 0, and the blue and the green. So depending on it, we can check it. And so now the main thing is to find the best performing model. We can find it based on the random forest model, or any random forest model, which will emerge as the best performing model for predicting the equipment status in the project. So this is the accuracy, precision, recall, and F1 score, which we were talking about before. And so these projects demonstrate the effectiveness of predictive maintenance using machine learning, and also the sensor data which is used in industrial settings. So these by accurately forecasting the equipment failures, any organization can they can proactively schedule they can maintain, they can say that there is a downtime, or the schedule maintenance, or optimize the resource allocation. So through the all what we have discussed, data processing, feature engineering, model selection, evaluation, so we can it will highlight in the effectiveness of random forest model in predictive equipment status. So that's how it is. Thank you.